Hello student, welcome to my official YouTube channel Mathematics All Level, and today we are in the part 3 of exponential and logarithmic function where we'll be discussing about the natural logarithm. At the end of this video, what you will learn that what makes E so special, why ln x is called the natural logarithm, how to differentiate and integrate exponential function, how to solve equations involving E. Okay, so what makes E so special? Let's talk about this. So if you'll Google it, so you'll get to know that the value of mathematical constant E is approximately 2.718. So that it emerges naturally from the processes of continuous growth and fundamental rule of calculus. How fundamental rules of calculus. So how we are getting this 2.718 is the story. I'll tell you. For example, if you are investing €1 at 100% annual interest, so how much amount you will be receiving after 1 year? I'm just taking an example for you. So after 1 year, it will be amount is given by P principal 1 plus of R by N raised to the power N cross T, where R is the rate of interest, N is the amount the money is getting compounded, it is yearly or quarterly or half yearly, and T is the number of and the time period for which the money is borrowed. So for example, for this case, for the first case, it will be amount equals to P, which is 1 plus of rate is again 100%, so it will be 1 by N, and again it will be 1 because we are compounding it for 1 year. 1 and N again raised to the power 1 cross of T is for 1 year, so it will be 2. Okay, similarly for second year it will be 1 for if this money, not for second year, if this money is getting compounded half yearly, means it will be the N will be 2 because the money is getting compounded half yearly. So it will be 1 cross of 2. So this is the amount after 2 years. Similarly, after 3 years, we'll be putting the here in 1 by 3 and the power will be 1 cross of 3. But at the end of, for example, if I say that particular money is getting compounded every day, so every day for it will be 1 by 1 plus of 1 by 3, 1 3 yeah, 1 plus of 1 by 365 raised to the power 1 cross of 365. So if you'll see that if this money is getting compounded every day, each day, so you'll see that if you calculate this, you will get approximately 2.715. This is the value which you'll be getting. So where it is tending towards, this money is tending towards this part, that E is equals to limit n tending towards the infinity, that money is getting compounded every day. If you want to take for seconds also, so you can take this also, and this is how this E came into existence. You will see that after this value, this term will be getting constant, means it will be reoccurring after every if you will raise the number here. So if you will put 1 by 366, you will get 2.715 only. Little bit difference will be there. So this is the story of the natural number E, how this value comes. Now let's talk about it. Why it is called natural logarithm, why this E is called natural? Because the gradient at any point equals the function value itself. For example, if you want to take the gradient, for those who don't know the gradient means slope, student. So dy by dx we used to calculate the gradient of any function value of the graph we are plotting. So if we want to take the gradient of that particular function, so what we need to do, we need to draw the tangent. This is how we need to get the gradient. So for example, if I say uh, at x equals to 0, you can see here that the value here will be 1. So gradient at x equals to 0 is e raised to the power 0, that is 1. Okay, so d by d means, I will not go in detail for this slope part, but you can see that at 0 point the value is 1. Similarly at 1, what is the value? You can see here we have drawn the tangent at 1, so it is equals to 2 raised to 2.718. So at power 1, the value is 2.718. Similarly at e raised to the power 2, it is something here, Yeah, 7 point of 3 type, 7 point of 3 or 4 like this. So you can see 7 point of 3. So this is the value of e, 2.718. E raised to the power 0 is 1. So e raised to the power 2 means 2.718 whole square. So here the gradients at any points equals the function value itself. So that this is why it is called natural, student, which I have shown you in my next slide as well. See, so at x equals to 0, 1, x1, at x equals to 1, it is 2.718, at x equals to 2, it's 7.3 here. This is the self-replicating property which makes it a natural exponential, or you can say natural logarithm. Okay, and e the most natural base for continuous growth base. Okay, so wherever you see that e is written, so it means with log e is written in the base, so it means it is a natural logarithm. So let's say, yeah, I've discussed this line, that wherever you see that with log x base is e, log x the base is e, it means the base here is e, it means that it is a natural logarithm. Okay, student, you can see I have told you this part, that at e equals to 0, log of 1 will be 0, means we are writing this in a transforming this into logarithmic form, so we will be getting log 1 equals to 0, log 1 equals to 0. Here the base will be e. Those who don't know that how I'm writing this part, you can see my first video. I've shown you the transformation of exponential to logarithmic form. So similarly, e raised to the power 1, it will be, this is how you need to write. This is the numerical solution, e raised to the power 3. This is the numerical solution. So, and all the logarithmic laws you have learned till now, the quotient law, the product law, the power law, all will apply for this log as well. Okay, no other laws will be applied here. Next, what are the properties of special properties of natural logarithm? Log e is equals to 1 means log e, ln, wherever you see that ln is written, it means that it is a natural logarithm, and it means the base here will be e. So obviously the base here will be e, so the log e base e will be equals to 1. This is an obvious part. Okay, similarly for this, log e, log 1 base e will be equals to 0. This is also an obvious part, because if you transform into an exponential form, it will be e raised to the power 0 equals to 1. Crucial property is e log x and equals to x, log e raised to the power x equals to x. Yeah, these are the crucial properties. See, student, I'll write it here. Yeah, e log e raised to the power log x. It means e raised to the power log of base e and x, log of x base e is equals to x. Okay, this is one of the property. Similarly, log of e raised to the power x and base is again e, so it will be equals to x. This is a kind of a, that power becomes the coefficient. This is the kind of a power, if you'll see it, if you analyze it correctly, which we have discussed in my previous video. This property which we have not discussed will be coming with this property as well in our next videos. So this is the crucial property here. The log x, the natural logarithm x, is on the power of e, so the value will be x here. Okay, this we have already discussed. This is the power law kind of. So you can see from here that e raised to the power x and ln x are perfect inverses. They undo each other. This we have already discussed here. You can see from here that e raised to the power x or log x base e are same. Now let's move to the next part, that is the differentiation of exponential function. Yes, student, that d by dx of e raised to the power x will be e raised to the power x, because we have discussed this part, that how we are getting the slope, that the slope of this particular function. So you can see from here that e raised to the power x will be e raised to the power x. I've shown you in my previous slides that at e raised to the power 1 it will be e raised to the power 1, but at the point 2 it will be e raised to the power 2. So this is a self-replicating property, so don't get confused. derivative of e raised to the power kx. Now we are having any number with x here, so the differentiation of this part d by dx will be k e raised to the power kx. Okay, now on the basis we need to differentiate this part, so according to our formula it will be d by dx of dy by dx will be equals to, for this it will be 3 e raised to the power 3x. Okay, this k here is 3, it will become a multiplier here, so this 3 will be outside and it will behave like a multiplier for this function. Similarly, for this differentiation, if you want to see, it will be equals to dy by dx of this function will be equals to negative of 2 e raised to the power negative 2x. Okay, because the power here is negative 2, so it will be coming out as a multiplier, so negative 2 will be, yeah, written as like this. So the dy by dx of this function will be negative 2 e raised to the power negative 2x. Okay, now for this function, don't get confused between e raised to the power kx. K was a number here, and yeah, k was a number here, and for e raised to the power function of x, it is a function. Okay, so if any function is there on the power of e, so you need to differentiate this function here. So it will be d by dx of e raised to the power fx. So it will be equals to, student, f prime x of cross e raised to the power fx. Okay, don't get confused between function of x and uh, kx. That is, the k will be a number and function will be in a function format. So I've taken you for an example for you, like for example dy by dx for this function e raised to the power x square. Now here you can see that raised to the power is x square is on the power of e, so it is a function, so it means d by dx of x square cross of e raised to the power fx. So this function will be written directly. On further calculating, you will get 2x cross of e raised to the power x square. Similarly, if I want to say for this, it will be dy by dx equals to d by dx of the function value, that is sine x, cross of e raised to the power sine x. Okay, so for this, the differentiation is cos x, so it will be cos x e raised to the power sine x. Okay, so what is the strategy here? So first identify the exponent, that whether it is a number, it is a function. If it is a number, so it will be directly written k e raised to the power kx, and if it is a function, so you need to differentiate it like this. Okay, student, let's move ahead. Yeah, now comes to for this function, that is natural logarithm. Wherever you will see ln x, it means it is a natural logarithm, means the base will be e. So the differentiation of d by dx of log x base e will be 1 by x. Okay, how it comes? It comes from that log x and ex. Log x and e raised to the power x are inverses using implicit differentiation, which we can make a video on this part as well in differentiation series. But for now, you know that for differentiation of logarithmic form of x with base e, natural logarithmic form of x will be 1 by x. Now for chain rule with ln x, whenever you are differentiating the log of a function with the natural logarithm, so the derivative of the inside is divided by the inside itself. It means whatever you are differentiating it, so it first you need to differentiate the function upon the denominator will be the function. For example, I'll take an example for you. We have given the question that y equals to ln 3x. It means 3x, the differentiation of 3x, it will be 3x. Okay, d by dx of 3x upon the function is 3x. So here the value will be 3 upon 3x. This 3 and 3 got cancelled, so it will be equals to 1 by x. Okay. Similarly, for this value, if I say d by dx of the function value, that is x square. So I'll write here d by dx of x square upon the function value, that is equals to x square. So on calculating it further, you'll get 2x upon x square. Now the power get neutralized here, so it will be 2 by x. This is the differentiation. Similarly, if I want to say about this, so it will be d by dx of, on the numerator, it will be the d by dx of differentiation of the function. It means x square plus 1 upon fx. Fx is here x square plus of 1. Okay, so it means that differentiation of the numerator will be 2x upon x square plus of 1. This will be the differentiation. Okay, student. So this is how we need to apply the chain rule, student, for the differentiation part of ln x. Okay, let's move further. Yeah, common mistake which you need to see here is, don't get confused between natural log 0 with 0. Log 0 means log of 0 base e, and 0 is 0. So don't get confused between these two terms. Okay, these two terms are not equal, by the way, and it will not be having any value also if you will see by calculating it. Yeah, majority of the student get confused with the chain rule applied here in e raised to the power fx. So it will be e raised to the power 3x square if I say. So this is a function value, student. So this is a function value. So the differentiation will be the differentiation of this function, that is d by dx of 3x square cross of e raised to the power 3x square. It means 6x cross of e raised to the power 3x square. This is the real value, not this one. Okay, many of the student, what they do, they differentiate the power and they write it directly, which is incorrect. This is the correct value. Okay, logarithm law misapplication, which we have discussed in our previous video also, that these two, this is a function value, so it will not apply the law here. Okay, so I have discussed this law in this mistakes in my previous video as well. Yeah. Next thing, the most important is the domain restriction part. Means log of, here you need to solve log, natural log is there, so the base will be e, x negative 2 equals to 3. So if I want to solve it, so it will be x negative 2 equals to e raised to the power 3. So from here you can see the value of x will be e raised to the power 3 plus of 2, which will be equals to 22.09, which we have calculated, which I have calculated it. So you need to see that is x minus negative 2 is greater than 0. So if it is greater than 0, it means that 22.0 means if I plug in the value of x, which we have calculated here 22.09, so you need to plug in this value in the domain. For knowing the domain, so you can see that 22.09 negative of 2 is 20.09, which is greater than 0, which is valid. So it means that you need to see this part, the function part. I'll highlight for you. This part should be, this part should be greater than 0, which I have discussed in my first video, student, that it should be positive, it should be greater than 0. Okay, so we need to see, we need to verify this as well. Okay, it must be greater than 0, then only it will be a valid point. So you need to see the domain restrictions here. Okay, student. Now let's move to the next part. Okay, first question I have done for you means we need to find the derivative of y equals to 5e raised to the power 3x square. So you need to identify the structure. First part I have done for you. The constant value is 5. The base here is e, and exponent here is, student, 3x square. So we need to differentiate. So we can differentiate directly. First, what we need to do, we need to see the function. Whatever the function is on the power of e, so it is 3x square, so differentiation will be 3x square, differentiation will be 6x. Similarly, apply the rule, so that chain rule which we have discussed, so it will be 5 cross of 6x cross of e raised to the power 3x square. And on further solving this values, so 5 cross of 6 will be 30, so this, the value of this will be 30x cross of e raised to the power 3x square. So this is the real solution of this question, student. Now I've taken certain questions for you. Let's do it. Let's see that e raised to the power 2x negative 1 equals to 12. Sorry. So we have given with this question e raised to the power 2x minus 1 equals to 12. What we can do here, we can take the first step is, student, take the take the log at both the side. So I will write it for you, taking the log both sides. This is step number 1, student. Okay, so what we will do, log of e raised to the power 2x negative 1 equals to log of 12. Okay, and the base here will be e. Okay, it will be beneficial for us. From here you can see that power law which we have discussed, so it will be 2x negative 1 will this power will become as a multiplier, so we'll left out with log e base e, and similarly here you will get log 12 base e. Okay, now we know that this log e base e equals to 1. Okay, this is the special properties. 2x negative 1 equals to log of 12 base e. On calculating it further, means transposing 1 to the right hand side, you will get log of 12 base e less of 1. So again, if I take 2 common, so we'll get 1 by 2. Now log of 12 base e less of 1. Okay. If I want to write it more, so we can write 1 by 2. I have told you whenever the base is e, so we can write it as ln 12, so plus of 1. Okay, so this is the final solution, student. This is the final solution. Okay, now let's move further. Yeah, I've taken next question here, and it's means this is also one of the most common questions for A level. And they can give the power here as 3x or e raised to the power 4x. But for now, we have taken e raised to the power x. How to approach this form, this question, student? So let's suppose, let's say e raised to the power x equals to y. Okay. So if e raised to the power x equals to y, so it means e raised to the power 2x will be equals to y square. Now plug in these values here. So what we'll get? We'll get y square negative of 5y plus of 6 equals to 0. Okay. On factorizing this part, so we'll get y square negative of 2y negative of 3y plus of 6 equals to 0. Taking common from the first two expressions, we'll get y negative of 2, negative of 3. I'm taking 3 common in the third and fourth terms, so you'll get negative of 3 out, y negative of 2 in the brackets equals to 0. Again, y negative of 2 is common in whole equation, so y negative of 2, y negative of 3 equals to 0. Okay, so now here two cases are possible, that is y negative of 2 is equals to 0 and y negative of 3 is equals to 0. For y negative 2 equals to 0, the value will be y equals to 2. Or similarly for y negative 3 will be, value will be y equals to 3. Now what we have supposed in the beginning is that y equals to e raised to the power x. So it means if we plug in the value y equals to e raised to the power x, it will be 2. e raised to the power x equal to 2. Similarly, e raised to the power x equals to 3. Here you can see that e raised to the power x equals to 2. So if I take log at both the sides, so you'll get log e raised to the power x log of 2. Which log we have taken? We have taken base as e here. So here the value will be x. The power log, the power will be uh, the power will be coming out as a multiplier. Here will be the value log of 2 base e, which could be written as ln 2. Okay. Similarly, taking log both the sides, you will get log of e raised to the power x base is e log of t base e. Again, the value here will be x log of 3 base e, which could be written as x equals to ln 3. Okay, so this is our final solution, student. X equals to ln 2 and x equals to ln 3. Okay, these two are the solution possible for this equation. So multiple questions could be possible from here. You can see in the previous year question papers also, they have given e power 2x, or it could be e raised to the power 4x as well. Now, next question for you I have taken is the population of bacteria is modeled by p equals to 1000 e raised to the power 0.5 t, where t is time in hours. Find the rate of growth when t is equals to 4. Now, rate of growth, which rate, whenever we are getting this expression term, rate of growth, so it means we are talking about the differentiation part. So p here is, student, is 1000 e raised to the power 0.5 t. So rate of growth means we need to determine the derivative of dp and this population of bacteria. So it will be dp by dt. It means if I differentiate it, so you'll get now 0.5 t, which is on the power of e, is a function value. So you need to differentiate this as well. So differentiation of 0.5 t will be, with respect to t, will be 0.5 cross of e raised to the power 0.5 t. Okay, so this is the rate of growth. Now they have told us when t is equals to 4, it means dp by dt at t equals to 4 means we need to plug in the value of t equals to 4. So it will be 1000 cross of 0.5 cross of e raised to the power 0.5 into t is 4 here, so we can write 4 here, which will be equals to 500 cross of e raised to the power 2. So this is the final solution, student, that after uh, 4 hours the bacteria will be 500 e square. So you can leave the solution here. This will be the correct solution. Okay, 500 e square. So these type of questions they usually ask in this A-level examination, and I'll be making the separate video also for whatever logarithmic questions they used to ask, means in A-level examination. Now we need to see the integration connect of this log of x base e. If d by dx, obviously integration and differentiations are inverse. So if d by dx of e raised to the power x is e raised to the power x, it means the integration will be opposite. So it will be, again, the integration will be e raised to the power x. Similarly, for e raised to the power kx, the differentiation part was ka e raised to the power kx. So for integration also, it will be the 1 by k e raised to the power kx. Okay. If you want to differentiate for log x base e, the differentiation was 1 by x. Now for integration, obviously it will be inverse of each other. So inverse of each other, which we have discussed in our previous slides. So it will be ln mod x. Okay. And this is the absolute value. This is the absolute value which used, means our students know this very well, that it must be an absolute value. It can't be negative. So this is the integration part. Okay, students. Now I'll whatever we have discussed here, that the definition of E is the natural exponential base. The value is 2.71828. ln x and log x base E both are same. They are natural logarithm. Okay. Inverse properties which we have discussed is e raised to the power ln x will be equals to x, which we have discussed in detail. Log e raised to the power x will be equals to x. Okay. For function e raised to the power x, the differentiation will be e raised to the power x. For the function e raised to the power kx, the differentiation will be k e raised to the power kx. For function e raised to the power fx, the differentiation will be f prime x into e raised to the power fx. Okay. For differentiation of ln x, it will be x by, sorry, the differentiation will be 1 by x. For the differentiation of ln fx, log of function value of x, it will be f prime x by fx, which we have discussed in detail. Okay. These are the major points, student, which we need to remember. Okay, now we need to see the strategy. This was the summary which we have discussed in this videos. Now we need to see the some strategy that how we need to solve it, for equation with e. What we need to do first, we need to isolate the exponential term. This we need to do first. Now we need to take the log of both the sides. Which log? ln, means the base will be e. Now use ln e raised to the power, that power law or whatever law is applicable there, and then we need to solve it. Okay, for equations with e. This is the common strategy. Okay, I'll write it. Now for differentiation, the strategy is, yeah, for differentiation, the strategy is that identify the structure, that whatever the power of e is written, whether it is in the form of kx, or it is in the form of fx, or it is normal x. So afterwards, what we need to do, we need to apply the chain rule. Okay, if it is with the power is having any certain number with x, so k e raised to the power kx will be the differentiation. If it is having any function, so the differentiation will be f prime x cross of e raised to the power fx. Then afterward we can simplify. Now for equation with ln, okay, whatever equation we are having with ln, first what we have to do, we need to isolate the ln term, that is the logarithm, the base is e here. Now what we need to do, exponentiate both the sides. Why we are exponentiating both the side with taking base e? Because majority of the cases the power will be coming out as a multiplier, so it will be helpful for us and we'll be getting the real value. So yeah, this only I've written here, and you use e raised to the power ln. It means that the two properties which we have discussed for the logarithmic properties, so this will be applied here, and afterwards solve and check the domain. Okay, log of this part which we have discussed, that m should be always positive, this should be always positive, it can't be equal to 0 and it can't be equal to 1, and this should be always greater than 0. So this need to be seen everywhere, the restrictions of domain, students. Okay. Okay, memory aids for you, e to the power unders ln. Okay, because the base will be logarithm, natural logarithm, the base will be e, so it will be and vice versa, which we have proven here. Similarly, ln unders e to the power, derivative of the exponent times the whole thing, derivative of insides over the inside for ln. Okay, this is the memory aid. You can download this ppt slides, student. I'll be sharing with my working uh, in this video description box below. I'll be sharing it with my video students. So this is our end of the lecture, students. We will be continuing with the graph of of all the forms of log in my next video. Hope you like my video. Stay tuned. Thank you.